This is something I've been planning for a long time. I mean, you've done a lot in the last few weeks, too.
Quite a long time. It's actually been a journey. By the way, let me just say welcome Cobb County and beyond to this beautiful, blustery afternoon. It's a little bit warm out here, but we hope to put on a great show for you. We were actually very fortunate to have the shell, for lack of a better term, donated to the school. This was about 2 years ago, and that's when the journey really began. There was many things that we had to do that we didn't anticipate. For example, once the shell was donated, then we had to find a suitable location for the observatory where there was clearance from the building and the trees. The next major step, once we decided to find where the best place to put it would be, is we had to run electric cable and fiber optics from the building, which we had to have crews come out and actually dig underground. Then once we had the cable and fiber optics put in, the next question, or I should say the next step in the process, was to build a base that you'll see. It didn't come with a base. So we had our construction classes actually build the base. Had the base built, we had the shell put on the base, then the fun part began. We needed to find telescopes, the right type of telescope, high-power telescope, computers, to be able to interface and use the software. So it's been a 2-year journey, but we're really excited to be able to bring something like this to all 115,000 students in 112 schools in Cobb County.
It's really amazing, and we're going to see a lot about it, and we're going to actually hear a bit more about all of the different steps you went through to get this here. Let's talk about all the students and teachers at this school who are involved and just making sure that this event happened today.
Right, and this is all student-driven. The entire afternoon is student-driven, from our video production class to our construction class, to our astronomy club, who you guys will see later, just giving some commentary and some play-by-play what you see. I also really need to thank Mr. Burkle Alexander. We had brought Burke over here. His forte, his specialty is really astronomy and the stars. So we brought Burke over here to help us with the observatory. He's been incredible throughout this. Miss Lexi Boltman, the administrator who oversaw this. Also Miss Jackie Collier and her video students. Mr. Jeremy Whitaker and his construction students. So literally from the ground up, even though everybody gets to see me, it's been the kids.
Yeah, it's been really great, and they've been wonderful to bring this, and it's quite a learning experience for everybody. We call it a teachable moment for a reason.
Right.
Yeah.
And we're just really excited that we're just able to showcase Kennesaw Mountain High School and be able to broadcast this to the entire county.
Yeah, well, we have students doing all kinds of things today. Among your students are some that are actually getting data for NASA today. And it's part of the Citizen Scientist program. And here's a story about that.
When the Earth goes dark for a few minutes during a total solar eclipse, animals, plants, and environmental conditions react. In the path of the eclipse, temperatures and clouds can change quickly. But exactly how they change is a question NASA scientists are trying to answer. If you'll be in North America during the August 21st eclipse, you can help NASA collect data for a citizen science project that's looking at how much cooler the Earth gets during the eclipse by measuring air temperature and clouds. How can you help? First, download the free Globe Observer app onto your smartphone or tablet. Second, get a thermometer to measure air temperature. See the website or app to see the suggestions of types you can get. The app will walk you through how and when to make your scientific observations. Your data will go into the Globe Program's database, where it's accessible to students and scientists from all over the world. Scientists can use this data to study how our solar-powered planet is affected by this special celestial event. You can collect data in many locations. The path of totality is roughly 70 miles wide and stretches across the continental United States, from Oregon to South Carolina. Outside of the path, the rest of the continental US and other areas will see a partial eclipse, where you can still collect data. We are looking forward to your observations. Download the app, create an account, and be ready to take part on August 21st.
Is a citizen scientist right here today. His name is Matthew Brown. He is a sophomore here at Kennesaw Mountain High School. And what he is doing right now is taking in all kinds of data. He's right in the courtyard, but we're going to go to him live. Matthew, tell us what you're doing right now.
Today we'll be recording different temperatures and barometric pressures during the solar eclipse. Right now we're having a temperature of about 33.5 degrees Celsius, which is about 92 degrees. And we're receiving a barometric pressure of about 99.103 kilopascals. Our friend Norbert, the bearded dragon here, is doing just fine. He's relaxing here and chilling, and we will update you all with more information. Now back to Mrs. Lowry.
Yeah, we're going to do a lot with this today, and you're going to keep us updated. So we're hoping it gets cooler as it gets darker outside. We'll see if that happens or not, Matthew. Now with me is Justin Cardona, and you are an aspiring journalist, so I'm really thrilled to be next to you.
Yes, ma'am.
So one of the things we have you do are Cardona reports. So you're going to talk about a few different things. Tell us what you've been up to.
I've been able to go around to the school and talk to KMTV students and see what they really thought Eclipse was. And I got a lot of interesting answers and a lot of really good answers, and this is what I learned.
In your own words, explain what an eclipse is.
Well, in this particular case, the eclipse that we're going to experience is where the moon comes between the sun and the earth.
When the sun is behind the moon and the moon is covering the sun.
Yes, it is.
I have no idea. It's when the moon covers the sun and then it kind of like leaves a shadow onto the earth.
Alright.
I'm thinking of lunar eclipse.
Okay, alright.
An eclipse is where the moon blocks out the sun.
I'm pretty sure it's when the moon covers the sun.
I think it's when the moon goes over the sun, just kind of covers it, and then it goes back out, and then like it makes it super bright.
An eclipse is like when the moon and sun pass each other, and we can see it from Earth because we're in that same orbit.
I think it's when the sun covers the moon.
No, other way around. It's the other way around. When
the moon covers the sun.
Okay. Alright, in y'all's own words, what is an eclipse?
The end of the world.
What?
The end of the world. Well, I think the reason a lot of those students actually knew a lot was because of this man who's joining me right now, who just got in the seat, because he is the guru for the observatory here. That's what I've named you.
Okay,
you know that.
I'll take it.
His name is Burkle Alexander, and he is an astronomy and physics teacher here at Kennesaw Mountain High School. And he's one of the reasons that the observatory even exists here. And we're going to talk more about that a little bit later. But let's talk right now about the fact that this is a day that teachers like you get really excited about, right?
Yeah, it was on my calendar about 5 or 6 years ago. And to have it here today with all this stuff, it's nothing like what I imagined it being. I thought it would just be me, Miss Collier, just streaming out to, our little school here. But I'm glad the county has really kind of embraced this and broadcast it for everyone to see.
Yeah, one of the things we want to, tell us right now, this is a live picture of what's going on.
Yes, it is.
Explain it.
Well, a lot's happening there. First off, it's an inverted image, so it would be actually coming from the west. But just because of the camera position, that's why it looks like that. But you can see at the top of the frame there, you can see some sunspots where you have these intense areas of magnetic fields, and you see the moon kind of gradually consuming the whole disk of the sun there.
So that's not dust on there.
Oh no,
it's not.
It's not dust. Those are actually larger than our planet, much larger than our planet.
Let's talk about this. One of the things that you've gone through is training, and I know you've been over to Georgia Tech. Talk a little bit about that.
Oh, I've been everywhere for training for this. This summer I went to San Diego for a robotics telescope conference. And Georgia Tech has really opened up their observatory to the general public. In Cobb in particular, they have viewing nights for Cobb teachers. I went there, met Dr. Saul, we hit it off. And yeah, so they have actually the same amount as we do. So.
Oh, I love that. And you had a chance to talk with him recently with some video production students with you, and we're going to take a look at what he had to say right now. Okay.
A solar eclipse doesn't come around very often, and scientists right here in Georgia are hoping that you take full advantage of this year's event.
I think that seeing the corona, seeing the totality of a solar eclipse is probably the #1 item on most astronomers' bucket list.
Dr. Jim Sowell is an astronomer at the Georgia Institute of Technology, or as most of us know it, Georgia Tech.
You're going to have to travel to go see him, and it's such a unique phenomena. I mean, there have been other great events. A nice comet is quite nice, but those tend to be much longer lasting, and a lot of people can see it. But even something like a lunar eclipse is also very nice. Just to see it happening up in the sky with your own naked eye, though, is truly wonderful for most astronomers.
He, along with other researchers, feel that the Great American Eclipse is pretty special.
It's so special because millions of people are going to get to see it. I mean, the whole country, if you're anywhere in the United States, you're going to see at least a 50% blockage, and that's fantastic. Here in Cobb County, you're going to see a tiny sliver if you're using your eye-safe equipment. You should notice a bit of a temperature change, some winds, birds might start to roost. It might get dark enough that streetlights are going to come on. So it's an experience that anyone can experience. Just take the time to go out and enjoy it.
The last time Georgia had an astronomical event like this,
there was one in 1984 that went over Atlanta, and it was about like what we're having this time as far as how faint the sun got.
But despite the excitement for the event, Dr. Sowell warns eclipse viewers to be totally safe, not partially.
There are eye-safe glasses, and the only thing you should be able to see through these is the sun. So, and the thing about the glasses, though, is you don't have to hold on to it for all 3 hours. You can share these. One pair of glasses is good for 10 students because the eclipse is slow moving. Eclipse will start around 1 o'clock and end around 4. The minimum time is going to be around 2:35.
The eclipse is more than just a cool phenomenon. It's a teachable moment in and out of the classroom.
I think it's great for all ages, and unfortunately, some people are still a little oblivious to the universe and space. About 5 years ago, a report came out that 1 out of 4 adults still thinks the sun goes around the earth. So here's a chance for people to be able to go out and to see for themselves what is happening. So you're going to learn in the classroom what's occurring and to actually go out and get to witness it. And in astronomy, that doesn't happen very often.
Even though the total eclipse will only last for a little while, big discoveries have come during these events in the past.
With solar eclipses, we've actually had 2 very special scientific discoveries. About 150 years ago, in the process of taking a spectrum as the moon's disk moves in front of the sun, taking a spectrum, you can identify elements. And some lines were there that nobody knew what they were from. And they named it after the sun, Helios. It's called helium. It was 30 years later that helium was found on the Earth. So we actually discovered that element in the sun's atmosphere before we found it here.
Another discovery helped to prove Einstein's theory of relativity while changing our understanding of gravity. And scientists this year are eager to see what else they might learn.
Well, a lot of the understanding of the sun we can do now with our own telescopes, but the understanding of how the atmosphere, the shadow, of the moon falling on our atmosphere is something that is going to be done during this eclipse. In fact, there's a Georgia Tech professor who's heavily involved with seeing how that works. So there's still going to be science from this eclipse that we're going to gain a new understanding.
And those understandings reach beyond the realm of astronomy. Physicists are hoping to gain more knowledge of gravity. Biologists want to see how the temperature change might impact animals. And then there's us.
And there's all kinds of science fiction and historical writings, because there have been eclipses in the past, and just to see how people would respond to that and to see how our changes of understanding have changed over time.
Unlike our changing superstitions, hopefully this will create a memory that will last a lifetime.
And so because this one is occurring, we want everyone to really see it and to understand what's happening and hopefully remember it the rest of their lives. Go, oh yeah, I understood what was happening and witnessed it, and tell others, the next time when one of these occurs in a few decades, how spectacular it is.
That's why we're here today, to experience it and find out how spectacular it is. So, Dr. Sowell is somebody who you admire and you got a chance to talk to recently. Let's expand a little bit on what he told you. Tell us about a solar eclipse, and you have some props for us.
Okay, sure. This is a model of Mars I use in my classroom. but it'll be a perfect sun for our situation.
Okay,
So
and I'm
that.
holding the sun.
Yes.
Okay.
Racquetball I bought at Walmart. That'll be the
Okay.
Earth, and a golf ball that Bonnie Wright bought me for use in my physics class.
Wow.
So it's got to be the
Pretty
moon.
impressive, yes.
So you have the Earth, you have the moon, you have the sun. The scale of this is way off, so that sun should actually be way out there.
Way out here.
Yeah, to
Okay.
match the angular
Okay.
size of this. So
Okay,
the angular
here.
size is just how wide this takes up in the sky, about half a degree in real life. So once the moon crosses in between the Earth and the sun, that's what creates the eclipse. There's a shadow that's cast on the Earth. And if you're in that path, in the darkest part of the shadow called the umbra, that's where you experience a total eclipse. So the reason why we don't have solar eclipses often, I mean, if the moon is going around like this, we'd have them, every month, right? But the moon is actually slightly inclined at an angle, about 5 degrees. And in space, these things are a lot further apart. So it's kind of very by chance that it intersects one of those lunar nodes when you get the perfect alignment between the sun, moon, and the Earth to create that eclipse.
Yeah, so what's happening right now? I want us to go to a shot a little bit of what we can see live from the telescope. So where are we now?
We're almost to totality. It looks about over 80% at least taken up. So we're almost there to our maximum, which will be 97. But yeah, the moon is just slowly, its shadow is slowly moving across the sun, and it's casting that on the Earth, so kind of a little crescent is there now. Wow. So we had first contact at 105. That's where the moon first intersects. Now we will pass that. We'll probably get into the maximum about 235 for Kennesaw.
And that's when you're going to give us the play-by-play of what's happening.
Yeah, this is a wide shot. We have another camera set up. It's not with a telescope, though. It's just kind of a raw image.
So we have a story right now, and you've explained that, and I love the props, but we have a story right now on the moon's role in a solar eclipse. Let's look at that.
A solar eclipse occurs when the moon moves between the Earth and the sun, blocks the sun's light, and casts a shadow on the Earth. When the moon completely covers the bright disk of the sun, that's a total solar eclipse, and it happens roughly every year and a half somewhere on Earth. A partial solar eclipse is more common, happening at least twice a year. A lunar eclipse, on the other hand, is where the moon moves behind the Earth, so it's now the Earth blocking the sun's light on the moon, creating a shadow on it with a red tint. The easy way to remember the difference is to remember what gets darker. With the solar eclipse, the sun gets darker, and during a lunar eclipse, the moon does. A solar eclipse is a rare event that not many get to see, because the moon's shadow is relatively small. This limits the locations on Earth that get to see it. You have to be on the sunny side of the planet, and you have to be in the path of the moon's shadow. So, if you find your area in the path of totality one year, you've hit the jackpot, because on average, that same spot on Earth will only get to see a solar eclipse every 375 years. During a solar eclipse, the moon casts a shadow with two parts, the umbra and penumbra. The moon's umbra is part of the moon's shadow where the entire sun is blocked by the moon. In space, it's a cone extending some 400,000 kilometers behind the moon. It's when the small end of this cone hits the Earth that we experience a total solar eclipse. Most eclipse maps depicting the path will show you a circle representing the shadow of the moon, but in actuality, the true shape of the umbra is more like an irregular polygon with slightly curved edges. This is because the moon isn't a perfect circle. It has mountains and valleys on its surface, which all affect the passing sunlight and subsequent shape of its shadow. And scientists now have a greater understanding of the shape of the moon's surface, thanks to NASA's Lunar Reconnaissance Orbiter. The unprecedented level of detail from the topographic maps, photos, and other datasets has allowed us to more precisely pinpoint the regions on Earth falling within the path of totality of a solar eclipse. So, if you get the chance to witness a solar eclipse, always remember that our little moon plays a role that's quite large.
Our little moon seems quite large right now as it's passing in front of the sun. So we want to talk a little bit about what we've had so far in the country since 1:05 this afternoon.
Okay. Well, started in Oregon, and then the shadow is just going to really just kind of bisect the entire United States. And it's almost in the Atlantic. I mean, if you can believe that, it's not that much farther to go until you're out in the ocean. So it's almost over, but yeah.
So it started?
Yeah, so the shadows here are pretty interesting. So the darkest part is the umbra, and then persons in the outer portion of that will get a partial. This is actually a great shot. So you see that's not a perfect circle, and that's because the scientists have looked at the moon's surface and like the mountains and valleys and craters on it, and they've interacted that shadow with the topography of Earth, so mountainous valleys and things like that. So it's not perfectly circular. And you could just see kind of all the cities that is crossing. Like a lot of people are getting to see this. Normally these things happen out at sea or, in the deep ocean because, most of the Earth is covered in it. And, a lot of times you got to go to sparsely populated areas and not that many people get to take advantage, but this is amazing. Millions of people are seeing this.
Yeah, and you're getting a chance to see it through the observatory here and the telescope here. So let's go to a shot again of that telescope so we can see exactly what's going on here from our vantage point at Kennesaw Mountain High School. It's getting a little closer, right?
Yeah, it's getting closer. 235 is our max. It'll be 236 in Atlanta. It'll take a couple of seconds for it to reach over there.
Yeah, well, we're at 222 about right now. So we're going to be talking with you more about all of this. In the meantime, what we're going to do is go back to our citizen scientist. Matthew, what are you seeing over there as this passes?
Yeah, okay. So far, our temperature has kind of decreased a few degrees. We are now at 32.1 degrees Celsius, which is close to about 90 degrees Fahrenheit, and our barometric pressure has dropped as well to about 99.052 kilopascals. Our friend Norbert the bearded dragon, he's still doing fine, he's still chilling. So nothing much has really occurred in the past few minutes. We'll update you guys again with any more details. Back to Miss Lowry.
Okay, well, I have Mr. Alexander here a little bit, and we're going to talk a little bit more about the sun. We focused on the moon. Talk about the sun's role in all of this.
Well, we're still very interested in the sun. If you can believe it, we don't really know a lot about it, even though it's right there. It's so bright that it sort of blinds us to its true nature. So the corona, which is the upper atmosphere of the sun, is actually way hotter than the surface. The surface is about 5,000 Kelvin or so. And but the corona is up to 1,000,000 degrees Kelvin. So you can imagine like the surface is actually cooler than up above, and we don't know why. So the guy who figures that out gets a Nobel Prize, right? So what you're seeing on screen there is a coronal mass ejection. So that's solar weather. So we have a satellite out in space that monitors that. So better we are predicting those things as we can become more technological. We need to protect our satellites and our infrastructure down below from coronal mass ejection. So in ancient times, they didn't have to really worry about that. They might have just seen a good show, a good aurora, right? But if that happens today and it's bad, our civilization stops because everything is electronic.
Wow. So. Yeah, we are a solar-powered planet, so that's what it's all about.
Lots of electrical stuff.
All right, then. Well, we're going to hear from you more later. I want to check in real quick. Matthew, are you ready to tell us anything new? What's going on with that animal you have over there?
Our animal here is Norbert. He's a bearded dragon. For the time that we've been looking at him, he hasn't really moved. I mean, of course, he'll move naturally as animals do, but he hasn't shown any signs that something is going on with the weather. He's doing perfectly fine.
Well, thank you. He seems to be just cooling out as everything's going on right there. Thanks so much.
You're welcome.
Well, with me again is Justin Cardona, and he's got his Cardona report. And what are you going to talk about this time?
We're going to talk about safety this time. So it's a really good thing Cobb County really took this so seriously and providing luckily our school with these glasses. We have the kids out on the football field right now observing this eclipse, and some of the kids had a little iffy answers when I was talking to them, so it's funny.
Yeah. So you got some interesting answers. Let's hear from them.
Yeah, let's learn.
What do you know about safety for the eclipse?
I know that you're not supposed to look at the sun.
that you have to wear like a special kind of glasses because you can get blind.
If you don't wear the glasses, you're gonna go blind.
Safety glasses. You need to be wearing your PPE. It's your personal protective equipment. Hard hat's not required, but glasses are a must.
Safety for an eclipse, you must have protective eyewear because if you don't have protective eyewear, you get blinded permanently.
What do you know about safety for an eclipse?
Well, I know it's just like looking at the sun during the normal day is dangerous to your eyes. So when you look at the eclipse, those same rays are coming down, but you don't think so because it's dark, so they burn your eyes just like it was in the middle of the day.
Protect your eyes.
Glasses.
Glasses.
Glasses. Glasses.
Glasses.
Or you'll go blind.
Yeah, so we have the glasses.
Yes, ma'am.
So everybody is prepared for this.
Oh, yes.
So you weren't the only one, only one person here looking at the whole safety issue. We had one of the teachers involved too, and we have her report next. Let's take a look.
Oh, hi everybody. I'm Dr. Joanne Jezequel, a science teacher here at Kennesaw Mountain High School, and I bet that you are as excited as I am about this upcoming eclipse. You know, an event like this doesn't happen very often. As a matter of fact, the next time a full eclipse is going to pass over this part of Georgia will be the year 2078. I'm going to be almost 125 years old by then. Oh my gosh. So, you know what? I was just going to talk to my AP psychology kids about some safety tips. Why don't you come in and listen in? As exciting as an eclipse is, it is so important to keep some safety tips in mind, because if you don't, you could permanently damage the inside of your eyeball. And that is nothing to kid about, because the damage is permanent. That means it doesn't go away, and it will impair your vision. So let me give you a couple safety tips that you have to keep in mind. As exciting as it's going to be, it is essential that you keep in mind how to protect yourself and how to take care of yourself, because if you happen to be outside, it is going to be tempting to look up into the sky because it's going to get darker and you're going to think, oh, I can sneak a peek, but you can't. You can't. You will damage your eyeballs. The retina, the back of your eyeball, will be burned permanently. And here's the thing, it doesn't hurt when that happens, so you wouldn't know it was actually happening. So normally this is what occurs, and you guys all know this. If you go outside on a bright sunny day, and let's say somebody wants to take your picture, and they say like, oh, just stand right there, and you say, okay, and you're standing right there, and they're like, smile, and you can't even do it. You can't even do it because the sun is so bright. That's what your body normally does to protect itself. You'll squint and your pupils will get really, really small. That's the part that actually hurts when you're looking at the bright sun. It's your pupils constricting. But during an eclipse, as it starts to get darker, you're not going to have that constriction, so it's not going to hurt, so you could get tricked into thinking that you're safe. Don't do it. Don't do it. There's only one type of glasses that it is safe to look at the sun with, and they are solar eclipse glasses. You wouldn't think that these little cardboard beauties would do it, but they do. But you have to know that you have the exact NASA-approved eclipse glasses. And the way you know that is that there's a little secret code here. There's a little secret code that's written on the glasses. It's an ISO lettering followed by a number, and that's how you would know that these are the official glasses. If your eclipse glasses are scratched or damaged in any way, it's not safe. It's not safe. So it has to be the solar eclipse glasses that you would put on. When I put them on here, I just want you to know, I can't see a thing. It is pitch black, blacker than black, pitch black. And that's how you know that these are safe to be able to look at the sun during an eclipse. You could do that. So let's go over a really important safety tip. Once you've established that you have your NASA-approved eclipse viewing glasses, you want to tilt your head down, put them on before you even think of tilting your head up towards the sky. And then, before you take them off, you want to tilt your head down and then take them off. Well, what if you happen to be outside and you don't have eclipse glasses and you're just dying to experience the phenomenon? Well, like I mentioned earlier, it's really cool. I've actually lived through an eclipse before, last century, and it gets darker and it gets colder in a matter of minutes. But you'll see weird shadows on the ground. You can use a little pinhole apparatus where you don't look at the sun. If the sun was behind me, you take a pin and a piece of paper, let the sunbeam go through the pinhole, and you can look at a piece of paper beyond that, and you will experience the whole phenomenon. Or you can even take your fingers and waffle them like Chick-fil-A French fries, sort of, and let the sunshine shine through the little squares that you're making and the shadows on the ground. You'll be able to see what's going on in the sky as well. So those are two things that you could do that are very low tech and would allow you to experience it if you are outside. Okay, so let's review a couple key pointers. You all have on your science safety goggles. But is it okay to look at the sun through science safety goggles? No! Question number 2. Is it okay to look at a solar eclipse when you have on a pair of sunglasses? No! All right, guys. Is it okay during a solar eclipse to sneak a peek even through your waffle fingers? No! All right, so what is the only safe way to look at the sun during a solar eclipse? NASA-approved solar eclipse glasses. That's right, everybody. And remember, I'll be keeping an eye on you.
We thank you for that. We have our glasses with us, and we've been talking about it. We have felt a change in the temperature already here as it gets darker. Let's first get a shot of what's going on and tell us where we are right now. We're getting here to the partial solar eclipse in our area, right? Yeah, look at that.
We're almost there. Yeah, that's almost what we'll get. So it's almost 235. That will be our max. That's a telescope feed. So you can see it's just a crescent sun that's left. So I think it's about to peak. And you could see the difference in the courtyard here. It looks like almost twilight, and it's very cool now.
Yeah, you really can feel the difference. Let's talk a little bit about the observatory. How did you get it?
Oh, that's quite a long story.
Tell us the short version.
Okay, short version. It was originally owned by Marcus Thompson. He was a NASA engineer up in Pennsylvania. He moved down to Kennesaw, Georgia, had a health issue, had a stroke, and unfortunately couldn't rebuild it at his new home. So he decided to donate it to his son's school, which happened to be this one. Yeah. So that's how we got the outer shell and the outstanding mount and the pier.
Yeah, and then to get a telescope, you did something cool. We have something called Cobb Tank, which is like Cobb Shark. I'm sorry, like the Shark Tank on ABC. Yeah. And so you were able to get the telescope. And while you're still sitting here, we have a student, Justin Cardona, has gone inside, and he is talking to some students about the telescope, because you've gotten a lot out of it as a teacher, haven't you? Okay, Justin, yeah. What are you hearing? And tell us what the students are saying about that telescope.
Thank you, Miss Lowry. We are here at the observatory now. We are with Morgan, Michi, and Alan, and they're going to tell us a little bit more about the observatory. There seems to be lots of moving parts in here. Tell us a little bit more about it.
So this is our telescope here. It's our main telescope. This here is the red mount, which stabilizes the telescope. It's able to move up and down to adjust for better viewing. This is our main viewing tube. It's an LX850, and it has a wide surface area, so it's able to capture a better picture than just the surface area of the eye. And here are the counterweights? The counterweights, and they help balance the telescope so that it doesn't become uneven in an event.
Okay. Wow.
All right, Justin,
Yeah, so
even though
those are
you
pretty much
guys
the
are
main
doing
moving
well in
parts,
there.
but none of this would work if we didn't have the
Okay.
software that we do right now.
Yeah, Justin is going to continue with his interviews, but we want to talk about, we're at the great moment right now.
Yeah,
Talk about
and
that.
it's so cool. I'm looking at the frame, and if you look at the outer moon's edge, you can see like the mountainous areas and like the valleys. I did not anticipate that. That's awesome. So yeah, we're there.
This is as far as it's probably going to go here.
Well, we'll wait a couple of minutes. It may get a little darker. We'll wait to see what the conditions are going to do.
Yeah. But talk a little bit about what people who are seeing totality.
Oh, people who see totality, they'll have a totally different show. Even though that little tiny portion of the sun is exposed, that little 3% portion, it's still really, really bright. I mean, it looks like it's daylight, right? Essentially. So, but if you're in totality, the entire sun is blocked out, and all that's left is a corona. So that's the outer atmosphere of the sun. If you're in totality, you'll get a chance to see the Bailey's beads, which are the little filters of sunlight that can get through the valleys and craters on the moon. You'll also see the diamond ring effect. So when once the moon makes its third contact, you'll see a bright flash of light that looks kind of like a diamond ring.
And the totality is so quick. It's
it's so quick. Depending on where you are, between 2 minutes and 7 minutes. I think for folks north of us, maybe 2.5 minutes, they'll get the totality.
Yeah, and so this might be it, where we're getting right now, as far as it's going to go. Is that it?
Well, possibly. I was hoping to see Mars and Jupiter and Venus. Those are actually right along the ecliptic path. So the sun arcs its path across the sky. We call it the ecliptic, and the planets orbit in that plane as well. So I was hoping we would see those guys next to it. But
have you ever seen one of these before?
Though. You know, when I was my son's age, my son is 6. He's in Miss Beam's first grade class. Hopefully he's watching. I remember going to a solar eclipse viewing, and this guy had I think it was like a 6-inch Celestron or something, and he had a filter hooked up to it, and he let me look through it. That was the first time I experienced one.
So this is the second time.
Yeah, it's the second time.
It's partial.
I can appreciate it more now, especially with all the effort that's taken into getting that shot. People have absolutely no idea how many hours were spent, like summers outside of school, like getting that together. So to see it come through and like interacting with so many people, like a large community effort at Kennesaw Mountain, like every department has had a hand in this. So.
Let's talk about this shot again. The shot that's not from the telescope, but from a regular camera.
Yeah, we've got a little Thousand Oaks optical solar film hooked up to it, just a small rig. We're hoping to get like a wide field shot. But you see, even with that little portion of the sun there, it's brilliantly bright, right? So, yeah, you can see just the sun, just a little bit of it is exposed there. Telescope filter is a glass filter. It's of the same company, so it blocks out a lot better. So that's why you're not getting like a large glare.
Yeah, so let's go back to the telescope shot and see what it looks like now. Yeah, I think it's starting to move the other way. What is it? I think it was more of a sliver before.
No, it'll
go a little more?
It'll go a little more, maybe.
Yeah. Well, while we're watching that, let's talk a little bit about the telescope that you were able to get through getting a grant through Cobb Tank, which is a way for Cobb County school teachers to ask for money for projects.
Yeah,
and you begged, I understand, for this telescope.
Yeah, that program was like a gift from God. It was a stressful gift, but I remember Dr. Engel and I used to work a lot, closely trying to, get it established. She was kind of my contact here. I was brand new. I didn't know anybody. And she said, hey, the county's giving away $10,000. I think we could use it. I say, yes, we could use it. So that's a shot of me and my son. He was in kindergarten then. That's Ella and Chris. They were 2 of my astronomy students at the first year here. That's actually an impromptu video that we shot just right there as we begged for money. So Miss Collier, I knocked on her door. She had no idea who I was. I say, can you help us out? She hooked it up. I messed up a lot, but she edited it so that I talked smoothly, so that was fantastic. So we entered that. There were lots of other teams there to compete. I had not watched the show Shark Tank, but apparently it's a big deal. And they had it all like it was, like it was a legit operation. So I went in there to get the money. So we pulled out all the stops. Had the little kid, Ella and Chris were on point. And I think we had a great argument. So. And I mean,
you won, obviously. You got the $10,000 grant for the telescope.
We got the money, but we also got another grant from Cobb Schools Foundation. They gave us the $2,500 before the Cobb tank, so that actually got us to actually break ground with the electrical. So that was done by a private company.
So we are, I think, seeing it go the other way a little bit. If we look
Yeah,
at
I
this
think
picture.
it's I think the image is flipped around. So yeah, I think it's going to the other side now.
Okay.
Yeah.
Let's continue to talk about getting this wonderful observatory here. One of the things we know you did was you had to reach out to somebody to actually get it built, and that was the construction students. And actually we have a story on what it took to get this observatory on the courtyard here at Kennesaw Mountain High School.
Hello, my name is Jeremy Whitaker, and I'm the construction trades teacher here at Kennesaw Mountain High School. The observatory project was a great project where it brought the CTAE department and the magnet department together for a great collaborative effort. From the outside, it might look like it's a simple deck that we built for the observatory, but it was very detailed. We worked closely with Mr. Thompson, the gentleman who donated the observatory to our school, whose son was in my construction program. The platform itself has over 10 4x4 posts and 2 feet of concrete, and actually the deck is not even attached to the platform for the telescope. There is a 2-inch spacing around the concrete base of the telescope so that if people walk on the platform, the vibrations of the housing of the observatory or the deck itself would not interfere with the images being captured on the observatory inside the telescope. So it was a great project for me and my students and for our school, and we're really satisfied with what this observatory is doing, not only for our school but for our community.
So as you can see, this was a project of the entire school. So there's a lot of pride in this observatory here. One of the things we've been doing is checking in with our citizen scientist, Matthew Brown. Matthew, what's going on now? We're seeing things get a little hot now, but what happened when the actual partial eclipse happened?
When the eclipse happened, we could see a drop in the temperature, definitely. It was around 30.9 degrees Celsius, which is about 87.5 degrees Fahrenheit. We could definitely feel that it got darker. It's like night was coming upon us, and we were able to hear some birds and some crickets. But now that it's going the other direction, you know, the light, you know, is kind of coming back up like it's daytime. So, you know, we really saw a change. Norbert, our friend here, he was kind of hiding, I guess, from the night, but, you know, he's kind of emerging now that the light is coming back.
So he likes the light, we know that.
Yes, he does.
All right, so we're thrilled that you are getting all this data, and you'll be passing it along to NASA right here at Kennesaw Mountain High School. Now we are now going to have more talking about this. We've got so many teachers here who know so much about what goes on with the eclipse. A lot of experts, and one of them is an assistant principal here who's going to walk on in. Come on in. Come on in. Her name is Lexi Boltman, and she is not only an assistant principal, but she is she was an AP environmental science person.
Yes,
right
I taught
here
AP
at Kennesaw.
environmental and biology.
Yeah. So let's talk a little bit about this. You know that this is an important time because it has a lot to do with everything we're dealing with our Earth, this solar eclipse.
Yes, I mean, it's just an interesting, event for our students, for us here. The students here have been really excited about it.
I just realized you don't have your microphone on, so they're going to work on that while you're talking. Maybe you can just hold it for us, okay? All righty. So,
better?
Yes.
Okay, excellent.
Absolutely. We know that eclipse does a lot of things to the Earth, right?
Yes. You can look at it from an energy budget perspective. You've got so much incoming solar radiation. A good portion of it actually is reflected by Earth's atmosphere. A good portion of that energy and heat and light actually make its way through the atmosphere. It's called insolation. And that's simply just the amount of energy received by a given area over a specific amount of time. If you look at the picture that's on the screen right now, on the right-hand side, you can see where it's dark. So that's nighttime. And you can see on the left-hand side, you can actually see the path of totality, and you can see where it's dark. And the colors are simply denoting temperature. So you can see kind of as it moves across, now you've got the United States, where it's warm in the eastern portion, you know, then you've got totality beginning. It's getting darker, it's getting cooler. As Matthew said, you know, temperatures dropped 20, you know, or 10 degrees here and there. So you can see the difference. And even here we noticed the birds began to chirp, you know, so a lot of environmental effects. Animals sense that, you know, when it's daylight, nighttime, those kinds of things. And so birds begin to roost. Like I said, we heard the birds chirp. You also have it where herding animals will begin to take shelter. So a lot of just changes regarding wildlife occur because, again, they sense that darkness is coming, night, and then, you know, it only lasts for a short time.
Yeah, I love that. And there's just even a vocabulary when it comes to this kind of thing. What are we seeing right here?
Oh, those, that's a shot through the leaves of a tree. So that's actually on the concrete. It's probably hard to tell, but you can see where, again, just through the sun or through the leaves, it's almost kind of like a pinhole camera where you see like little crescent moons everywhere.
All over.
So it's just another way to naturally view the eclipse without having eclipse glasses.
Yeah, well, we've had I can't believe it's over. It went so fast.
Like that.
That's part of it. So we were going to talk a little bit about that vocabulary when it comes to the eclipse. We have a story about that right now.
Just as the sun is part of weather on Earth, it also affects weather in space. The sun creates solar wind by steadily releasing a flow of plasma particles in all directions around it. Sometimes the sun gives off a flash of light and X-rays. This is known as a solar flare. When massive bursts of particles explode into space, we call it a coronal mass ejection, or CME. When a CME is directed toward Earth, it hits the magnetosphere, the magnetic field around our planet that protects us. If the storm is large, we may even get to enjoy a light display in the sky called the auroras. In space, satellites may be damaged, and astronauts should take cover. On Earth, people do not feel any physical effects. We may lose electricity in some areas, polar flights may be rerouted, and satellite services may be disrupted. While these situations aren't ideal, they are rare and fixable. This is why we will continue to study the sun and its interactions with Earth and the solar system.
We can certainly tell that it's a lot hotter out here than it was earlier during that period of time. It kind of got cool and it came back a lot hotter. With me now is another assistant principal. They have so many wonderful teachers here. He's also athletic director here at Kennesaw Mountain High School, Don Baker, and you're an historian when it comes to things involving the eclipse. Talk about what it used to be like for those who experienced it in ancient times.
Well, when you look at the eclipse, it's been documented as long as people have been documenting things. We've got evidence of it from ancient China to Egypt to Europe to South America, as well as North America with the Native Americans. And so the ancient peoples were much more in tune to the heavens. I know this is going to shock a lot of school-age children, but there was no TV, no Netflix, no Xbox. At night, people looked at the stars. They were much more aware of the stars and the moon, especially the Mayans. One of the theories that they had with the eclipse is that it was a serpent that would eat the sun, almost as a way to warn people that if they didn't follow the rules of the world, that they would get things taken away from them. And so kind of a cautionary symbol. Also, you see in other parts of the world where it's seen as a unifying symbol. This idea of daytime and nighttime, the sun and the moon coming together as one, even resulted in the ceasing of conflict between nations as a peaceful force.
So a solar eclipse would kind of bring people together.
Yes, absolutely.
Yeah, and so they had some theories too about what was going on, right?
Yeah, well, you have, the Mayans, they had their issues with either a serpent or a snake eating the sun. Also, you have the Vikings. They looked at it as a wolf that would run across the sky and eat the sun, so to speak. So just really depends on where you were in the world, but it could be either a cautionary symbol or one of unity and peace. So really cool deal, but definitely been documented for quite some time and all the way up until today.
Oh, so what did you think? I want us to show that picture from the telescope if we could, and I want to know what you actually thought actually seeing it today.
Oh, it was fantastic. It was great, being able to kind of see the change in the environment. The thing that got to me was the change in temperature, how almost immediately it became much cooler. And like Ms. Boltman said, that, being able to hear the birds chirp and kind of, they were aware that something had changed. And I felt like that was really, really cool.
So we're seeing that it has moved quite a bit now as it moves on the other side. Well, thank you very much. That was fascinating.
Not a problem, not a problem. I hope that, my son is at Pickett's Mill. I hope he has his glasses on. My daughter, they're watching us right now. So Miss Hilliard's class and Bailey, good. I hope you enjoyed it.
I love the shout outs. I really do. I think they're great. Speaking of shout outs, let's go to Matthew right now. Matthew, I don't know if you're ready to tell us a little bit about what you saw out here and what's going on right now.
Yeah, most definitely. As we come over here, we can use this apparatus, and as we look down on the concrete, we can see definitely eclipse.
You want to go to
kind of forming. We have a little star here to show the capital of Georgia, and then we have just a little circle. But as we look through, we can definitely see part of the eclipse that's still there, and we can feel the humidity, and the light is still coming back. So, yeah, it was a great eclipse. Now back
shadow,
to you.
yeah, I love the shadow that you had there. It was pretty cool.
Yeah.
So, did you see a change? I don't know whether you actually showed your shadow, looked at your shadow during the eclipse.
No, I didn't. But what I did was kind of waffled my fingers and made squares on the concrete, and I was able to see the eclipse through my fingers.
Yeah.
It was really
Are you
cool.
disappointed it went so fast? It's kind of.
Yes, I am. I wish it was longer.
There was a whole lot of buildup and it went so fast. Well, thank you so much,
Thank
Matthew.
you.
And I'm so glad that NASA will be able to get some of what you have collected today.
Yep.
Thanks. All right, now, Virgil Alexander, wow, how do you feel about things? First of all, let's get another shot from your telescope.
Okay.
How do you feel about this day?
Well, I actually just put on a pair of glasses. I actually just saw it.
You kind of missed it because you were under this tent with me.
Yeah, we got to see some of it though,
Yeah,
but it's naked eye is good too.
Yeah.
So yeah, it was great. So I was thinking about like all of the data that's just pouring in from all across the country about information as far as the temperature, the citizen science thing, and also high-profile projects like the 2 high-altitude planes that's going to study the corona. And lots of other studies that are going on to try to understand more about the sun.
So yeah, what will this mean down the road in terms of what we know about our Earth and the sun and the moon?
Well, I look at this as just, a stepping stone, right? We're trying to cultivate the next generation of young scientists. And, as a teacher and a parent, you want to hook kids in the right direction. And this is the perfect bait. I mean, think about how many students are watching and are excited about this, seeing this for the first time. The infrastructure is already here in place at Kennesaw Mountain High School and other places to facilitate the type of science and critical thinking that's needed, to advance our cause. So as a race, we've got to leave this planet at some point, right? So we're beginning to become a Type 1 civilization where we'll be able to use, the entire energy source of our planet, and understanding the sun is a big part of that. So. This is just amazing on so many levels, right?
Yeah, it was a way of actually showing people who didn't realize that we were a solar planet, that we're solar powered, that this really is who we are, a solar powered planet.
Yeah, we're trying to get that way. We're trying to get that way.
The sun has so much effect on everything.
Yeah, it's so much effect, and we're using so little of it, right? Because most of our energy is coming from fossil fuels and other sources like that, but we're trying to transition to that, and like I said, understanding the sun is a big part of it. There's lots of studies and lots of money being poured into the next generation of fuels and technologies. So, and it's our students, it's Cobb students that are going to be at the forefront of that. I like to call us like the mini Silicon Valley. I went to San Diego, and that's what they called us. That's what they called Atlanta. This area, Metro Atlanta.
Nice.
I mean, we're coming up. I think we have a lot of people that are doing the right things and realize that things like Cobb Tank should be funded, because what makes teachers better, makes students better, what makes students better is ultimately good for the country and our overall well-being, right?
Okay. Well, thank you so much for being here. I've learned a lot, and I hope a lot of the people here have. Those of you who've been watching, we're winding down the show. We're going to try to keep showing you shots from the telescope here at Kennesaw Mountain High School, so you get a chance to see it as it continues to go by. Lots of people have worked on this show, and we're going to show you those credits in a minute. But at the district level, with technology, the communications department, the students here in video production. Actually, there's students and teachers from all levels here at Kennesaw Mountain High School who are involved in this, and we are thankful to all of that. Special thanks from me to David Owen and Josh Dempsey with the communications department, who have, I don't think, slept in the last few days as they prepared for this. But a lot of people involved. You'll see those credits in a minute. For all of us right here at Kennesaw Mountain High School, have a great post-solar eclipse afternoon.